Hello, and welcome. I am very happy to have you here as we begin this journey together. Please make yourself comfortable, find a quiet place to sit or lie down, and let us prepare to explore a story that is as old as the universe itself. Let us begin by taking a deep breath. Close your eyes and let the noise of your daily life fade away. Imagine you are floating upwards, leaving the ground, leaving the atmosphere, and drifting into the vast velvet silence of space. Above you and around you there is only the deep, endless dark, or scattered with the diamond dust of distant stars. Think about home, the solar system. For millions of years it has been a place of order. It is like a giant perfect clock. The planets move in their lanes, silent and obedient. Jupiter spins its massive storms. Saturn guides its rings of ice. And our Earth, a tiny blue marble, sits safely in the warmth of the sun. We have always felt safe here. We look up at the night sky and we see constancy. The North Star is always where it should be. The constellations tell us the stories of our ancestors. We believe that we understand our neighborhood. We believe that we are alone in our quiet corner of the galaxy, protected by the vast distances of space. We have spent decades scanning the skies, listening for signals, watching for danger, and finding only the comforting hum of empty space. We felt secure in our isolation, but that feeling of safety was an illusion. It was a fragile glass wall, and in October of the year 2025, that glass began to crack. It happened quietly at first. There were no explosions, no alien invasions, no flashes of light in the sky that everyone could see. It started as a glitch on a radar screen. It was just a string of numbers that did not make sense. Deep in a remote observatory high on a mountain where the air is thin and cold, an astronomer blinked his tired eyes at a computer monitor. He thought it was a mistake. He thought perhaps a sensor had failed or a piece of software had calculated a wrong trajectory, but the numbers did not change. An object had crossed the threshold of our solar system. It did not move like a comet trailing a long tail of ice and gas as it warmed up near the sun. It did not move like an asteroid tumbling aimlessly through the dark. It moved with purpose. It moved with a speed that defied the gravity of our sun. It cut through the plane of our planets like a needle piercing through fabric. In the weeks that followed, the world began to hear the official story. The news channels and government agencies were calm. They told us not to worry. They used soothing voices and smiling faces. They said, "We have detected a new interstellar visitor similar to the one we saw years ago, called Oumuamua." They told the public that it was just a rock, a piece of Deiru wandering between the stars. They gave it a scientific name, 3I/Atlas. They said it would pass by us harmlessly, just a tourist taking a quick look before leaving forever. However, in the quiet corners of university laboratories and in the encrypted chat rooms of astrophysicists, a different story was being told. The scientists were not calm, they were sweating, they were arguing, they were terrified. Because they saw the data that the public did not see. They saw that this object was not tumbling, it was stable. They saw that it was correcting its course ever so slightly against the pull of gravity. And most disturbing of all was the chemical analysis coming back from the spectral telescopes. The light reflecting off this object was strange. It did not look like rock or metal or ice that we know. It looked like something else entirely. While the world continued to go to work, pay bills, and watch television, the eyes of the scientific community were locked on this intruder. And as they looked closer, they realized the first and most terrifying truth about our visitor. This brings us to the concept of time. Time is a difficult thing for us to truly understand because our lives are so short. We live for maybe 80 or 90 years. To us, 1,000 years is a long time. To a mountain, 1,000,000 years is just a nap. Think about our planet Earth. Our home is old. It was born from a cloud of dust and gas about 4.5 billion years ago. 4.5 billion. That is a number so big it is hard to imagine. In that time, continents have crashed together and torn apart. Dinosaurs have risen and turned to dust. Oceans have filled and dried up. We respect the Earth because it is ancient. We think of it as the foundation of everything we know, but 3I/Atlas laughed at the age of the Earth. When the sensors analysed the isotopic decay, the faint radioactive signature of the object, the results were impossible. The machines were checked and rechecked. The scientists thought their equipment was broken, but the answer remained the same. This object was not 4 billion years old. It was not 10 billion years old. It was approximately 14 billion years old. Let that sink in for a moment. The universe itself is estimated to be about 13.8 to 14 billion years old. This implies that the object entering our system is nearly as old as the universe itself. It is older than our sun. It is older than our Earth by nearly 10 billion years. It is older than the carbon in your body. It is older than the iron in your blood. When this object was formed, our solar system did not exist. There was no Earth, no Jupiter, no Sun. There was only a vast dark cloud of hydrogen gas waiting to collapse. This object, this atlas, has been travelling through the dark since the very beginning of time. Imagine the journey it has taken. Close your eyes again and try to see it. Imagine a smooth dark shape moving through the absolute blackness of the void. It was there when the very first stars ignited, lighting up the dark universe for the first time. It drifted past them as they burned blue and hot. It was there when those first stars died, exploding in massive supernovas that scattered gold and oxygen into the cosmos. It flew through the shockwaves of those explosions, untouched, silent and moving forward. It has sailed through the great emptiness between galaxies where there is not a single atom of gas for millions of light years. It has endured temperatures of absolute zero where time itself seems to freeze. It has passed by nebulae giant clouds of purple and red gas where new solar systems were being born. It watched them spin into existence and continued on its way. It is a time capsule. It is a witness to everything that has ever happened. If it had eyes, it would have seen the birth of the Milky Way galaxy. It would have seen the collision of ancient galaxies. It has travelled a distance that we cannot measure in kilometres or miles, but only in eras and eons. And now, after 14 billion years of lonely travel, after passing a billion other stars and ignoring them all, it has decided to come here. It has decided to enter our tiny, warm, insignificant solar system. Why? That is the question that kept the scientists awake at night in October 2025. A rock does not travel for 14 billion years just to accidentally hit a target as small as our solar system. The odds are mathematically impossible. It is like throwing a grain of sand from one side of the ocean and hitting another grain of sand on the other side perfectly. No, this was not an accident. The official report said random trajectory, but the whispers in the lab said arrival. This object carries the history of the universe in its dark hull. It comes from a time before us, before life, before home. It brings with it the cold memory of the void. And as it moves closer to Mars, passing the orbit of the red planet, we realize that we are like children playing in a sandbox who have suddenly noticed a giant standing at the edge of the playground. We are not as old or as wise or as safe as we thought we were. The darkness has woken up and it has come to knock on our door. This is the reality of the awakening. It is not a monster jumping out of a closet. It is the realization that we are very young and something very old has finally found us. Fact 11. The thick disk origin. To truly understand why the origin of this object is so shocking, we first have to look at the map of our own home, the Milky Way galaxy. We tend to picture our galaxy as a flat, perfect spiral like a spinning dinner plate or a frisbee. However, the reality of galactic architecture is more three-dimensional and complex than that. Astronomers divide the galaxy into two main distinct structural components regarding where stars and matter reside, the thin disk and the thick disk. The thin disk is where we live. It is the modern bustling downtown of the galaxy. It contains the Sun, the Earth, and most of the stars we see in the night sky. It is a region characterized by order. In the thin disk, stars orbit the galactic center in a relatively flat plane, much like cars driving neatly in lanes on a highway. This area is rich in gas and dust, which are the ingredients for making new stars. Consequently, the thin disk is young, vibrant, and constantly regenerating. The thick disk, however, is entirely different. Imagine a puffy layer of stars enveloping the thin disk, extending much higher above and lower below the galactic plane. This is the attic and the basement of the galaxy. The stars here are not young, they are ancient. They are the seniors of the stellar population, often billions of years older than our Sun. Furthermore, their movement is not neat and orderly. Stars in the thick disk have chaotic high-energy orbits. They do not just go around the center, they dive up and down, plunging through the galaxy's plane at steep angles and high speeds. The analysis of this object's incoming velocity and angle tells us it did not come from the calm-orderly neighborhood of the thin disk. It came from the thick disk. This has profound implications. First, it suggests extreme age. If this object originated from a star system in the thick disk, it likely formed billions of years before our solar system even existed. It is a relic from a forgotten epoch of the universe. It has survived a journey through the roughest, most chaotic parts of the galaxy, dodging the gravitational pull of countless stars over eons. Secondly, there is the mystery of metallicity. In astronomy, the term metal refers to any element heavier than hydrogen and helium. Usually very old stars in the thick disk are metal poor, because they formed before the universe had created heavy elements like iron, gold, or silicon. However, for an object to be solid and rigid enough to survive this journey, it implies it must be metal-rich. The idea that a solid manufactured-looking object could originate from the oldest, most chaotic part of the galaxy challenges our understanding of when and where technological civilizations could have arisen. It implies that while Earth was still molten lava, a sophisticated traveller was already navigating the rough currents of the thick disk. Fact 533 billion tons. When we look at celestial objects, mass is usually just a number on a page. But in this specific case, the estimated mass of the object changes everything about how we categorize it. Based on its size, dimensions, and the way it reflects light, researchers have attempted to calculate how heavy this object would be if it were made of different materials. The results lead us to a staggering figure, approximately 33 billion tons. To put that number into perspective, let's compare it to things we know. The Great Pyramid of Giza weighs about 6 million tons. The total weight of all human beings on Earth combined is roughly 300 million tons. This single object drifting silently through space possesses a mass roughly 100 times greater than the entire human population. Why is this figure considered impossible or anomalous? It comes down to density and structural integrity. In our solar system, comets and asteroids are the most common wanderers. We know them well. Comets are often described as dirty snowballs. They are loose collections of ice dust and rock. They are not solid blocks, they are porous and fragile. If you were to hold a piece of a comet in your hand, it might feel as light as styrofoam or pumice stone. Because they are so light and fluffy, they are very large for their weight. If this visitor were a natural comet with that specific size and shape, it should be relatively light. However, the way the object spins suggests it is heavy. It is tumbling. When a loose porous pile of rocks like a natural asteroid spins rapidly, it flies apart. Centrifugal force tears it to pieces. A rubble pile asteroid cannot hold itself together if it spins too fast or is too heavy. The fact that this object has an estimated mass of 33 billion tons implies it is incredibly dense. It is not a fluffy snowball. It suggests the object is made of something solid, cohesive, and incredibly strong. It suggests a density comparable to solid iron tungsten or a high-strength artificial alloy. A natural rock of these dimensions generally does not achieve this kind of uniform high density. Nature tends to make things chaotic and mixed. A structure that is small, elongated, and yet weighs 30 billion tons, without collapsing under its own gravity or flying apart from its spin, implies a coherent single-piece structure. It implies a hull. It implies that we are not looking at a random geological formation, but rather something built to withstand the harshness of interstellar travel. The weight is not just a statistic. It is evidence of a protective, armoured nature that a simple space rock would never possess. Fact 13, highest eccentricity. In the language of orbital mechanics, eccentricity is a measure of how much an orbit deviates from a perfect circle. It is the number that tells astronomers the shape of a path through space. If an orbit is a perfect circle, the eccentricity is 0. The Earth's orbit around the Sun is very close to 0. If the orbit is an oval or an ellipse like a typical comet that returns every few years, the eccentricity is between 0 and 1. However, if the eccentricity is greater than 1, the object is following a hyperbolic trajectory. This means it is not orbiting the Sun at all. It is a one-time visitor. It comes in swings past and leaves forever, never to return. Before this object arrived, the highest eccentricity we'd ever seen for an object in our solar system was roughly 1.05. That is barely hyperbolic, usually caused by a comet getting a little kick from Jupiter's gravity. This object, however, arrived with an eccentricity of roughly 1.2. This is not just a record breaker, it is a record shatterer. In the world of physics, a jump from 1.0 to 1.2 is massive. It indicates that the object was not loosely wandering through the galaxy, gently falling into our gravity well. It indicates that the object was moving with purpose and tremendous energy. This leads us to the velocity. The object entered our system moving at approximately 26 kilometers per second while it was still far away in deep space. As it fell toward the Sun, gravity accelerated it to a blistering peak speed of roughly 87 kilometers per second. But the most telling number is its excess velocity, the speed at which it is leaving us. It is exiting our system at about 58 kilometers per second. To understand how fast 58 kilometers per second is, a high-velocity rifle bullet travels at roughly 1 kilometer per second. This object is traveling nearly 60 times faster than a bullet. The fastest spacecraft humanity has ever launched, Voyager 1, is traveling at about 17 kilometers per second. This object is moving more than 3 times faster than our best technology. The trajectory reveals the intent of the motion. A flat trajectory in this context refers to the unperturbed nature of its path before it hit our solar system. It did not meander. It did not look like a leaf floating on a pond drifting wherever the current took it. It looked like an arrow. The specific path it took is also telling. It dropped into the solar system from above the ecliptic plane, the flat level where planets' orbits swooped down near the sun and shot back out. This is the classic maneuver of a gravity assist or a slingshot. We use this same technique with our own space probes. We fly them close to Jupiter to steal a bit of energy and speed up. Because of its extreme eccentricity and speed, the sun's gravity could not capture it. The sun tried to pull it into an orbit, but the object was simply moving too fast. It treated the sun not as a destination, not as a star to orbit, but as a buoy to turn around. It used our home star merely as a way station, a gravitational pivot point to adjust its course and accelerate toward its next target in the Pegasus constellation. This flat, high-speed, hyperbolic path is exactly what you would expect from an interstellar probe on a grand tour of the galaxy. A natural rock wanders, it gets caught by gravity, it crashes or settles into an orbit. This object did none of those things. It ignored the speed limit signs of our solar system. It arrived with high energy, executed a perfect turn, and departed with even higher energy. It behaved less like a piece of debris and more like a ship under orders, strictly following a flight plan that considers our solar system nothing more than a brief refueling stop on a journey that has lasted for millions of years. We have looked at how the object moves and where it came from. Now we must look at what it is made of. This is where the story shifts from physics to chemistry, or what we might call interstellar alchemy. When astronomers looked at the light bouncing off this visitor, they found clues that simply do not fit the standard recipe book of the universe. Factor 4, nickel without iron. To understand why this is so shocking, we first need a very simple chemistry lesson about how the universe builds things. In the vast darkness of space, iron and nickel are like twins. They are almost always found together. This is because of how stars die. When a massive star explodes in a supernova, it creates heavy metals. Iron and nickel are very close to each other on the periodic table, and they form under similar conditions. When that dust settles to form asteroids and planets, these two metals remain mixed. If you pick up a meteorite that has fallen to Earth, or if you analyze the core of our own planet, you will find iron mixed with nickel. Usually it is mostly iron with a smaller percentage of nickel. This is the natural order of things. It is the fingerprint of a natural formation. However, when scientists analysed the spectrum of light coming from this interstellar object, they found something that should not exist. The data suggested a composition that was rich in nickel but strangely lacking in iron. In nature, separating nickel from iron is incredibly difficult. It does not happen by itself. You cannot just break a rock open and find pure nickel inside. To separate them requires a lot of energy and a specific chemical process. On Earth, we call this the Mond process. It is an industrial method used to refine nickel. We take the raw ore, which contains both metals, and we treat it with carbon monoxide gas at specific temperatures. This chemical reaction pulls the nickel out, leaving the iron and other impurities behind. It is a complex factory process, not a geological one. This leads us to a startling conclusion. If this object is made of high concentration nickel with very little iron, it implies that the material has been processed. It suggests that the metal did not clump together by gravity in a dust cloud, but was perhaps refined in a furnace. Finding a nickel-only object in deep space is like walking through a forest and finding a perfect cube of stainless steel sitting on a tree stump. You know immediately that the tree did not grow the steel cube. Someone or something had to build it. If the object is indeed a solid block of refined metal, it supports the theory that this is not a random space rock, but a manufactured probe built to endure the harshest environments of the galaxy. Fact 9, the metallic surface. If the composition of the object is strange, the way it interacts with sunlight is even stranger. This brings us to the mystery of its surface texture. Astronomers learn about objects they cannot touch by studying albedo. Albedo is a fancy word for how much light a surface reflects. Think of the difference between wearing a black t-shirt and a white t-shirt on a sunny day. The white shirt reflects light, the black shirt absorbs it. In space, rocks are usually quite dull. They are rough, covered in dust and pitted with craters. They scatter light in all directions, making them look somewhat fuzzy and dim to our telescopes. Ice is different. Ice is bright and shiny, acting almost like a mirror. This interstellar object presented a puzzle. Its brightness changed wildly as it tumbled through space. At its peak, it was 10 times brighter than at its dimmest point. While this told us about its long cigar-like shape, it also told us about its skin. The way the light was polarized gave us the biggest clue. Polarization describes the angle at which light waves vibrate after they bounce off an object. When sunlight hits a rough rocky surface, the reflection is messy, but when sunlight hits a smooth shiny surface, the light waves line up in a specific way. The data from this object suggested it was not a fluffy ball of dust or a craggy rock. It behaved more like a polished surface. Imagine a piece of metal that has been buffed until it shines. Now imagine that object tumbling through the dark. When the flat side catches the sun, it sends a blinding flash of light toward the Earth like a signal mirror. This is consistent with the solar sail theory, a probe designed to be pushed by light itself. But even if it is not a sail, a metallic surface makes sense for an interstellar traveller. Space is not empty, it is filled with tiny dust grains and high-energy radiation. A rock travelling between stars for billions of years would slowly erode. However, a smooth metallic shell acts as armour. It suggests a design intended to survive the eternal journey. This creates a powerful image in our minds, not a wandering asteroid, but a sleek armoured vessel. It is sealed and shielded, designed to deflect the tiny bullets of cosmic dust, protecting whatever or whoever might be inside. The reflectivity tells us that this object was not just formed, it was finished. It has a hull. Fact 15, the red continuum. Finally, we must discuss the colour of the object. In astronomy, colour is information. When we look at the light spectrum, specifically the infrared or red sections, we are looking at the chemical history of the object's surface. This object was not grey like the moon, nor was it blue like Earth. It possessed a distinct deep reddish hue. In the scientific data, this is often called the red continuum. At first glance, this might seem to contradict the idea of a shiny metal ship. If it is made of refined nickel, shouldn't it be silver? Not necessarily. In our own solar system, the colour red is usually associated with TNOs, or trans-Neptunian objects. These are small icy worlds that live far beyond Pluto. They are red because of something called tholins. Tholins are not a specific mineral, but a class of organic compounds. They are what happens when simple carbon molecules like methane are bombarded by cosmic radiation for millions of years. You can think of tholins as the rust or the sunburn of the outer solar system. It takes a very, very long time for this red layer to build up. So we have a contradiction. The movement and lack of a tail say it is not a comet. The reflection suggests it is metal, but the colour suggests it is covered in ancient organic gunk. How do we resolve this? One possibility is that the red colour is a sign of extreme age. This object has been travelling through the void between stars for eons. Even if it started as a shiny silver probe, millions of years of exposure to the harsh radiation of deep space would cook any carbon atoms on its surface, creating a layer of red organic dust. Think of it like an old car found in a desert. Underneath the frame is steel, but on the surface it is covered in a layer of red dust and oxidation. The red continuum might just be the patina of history. However, there is another, more fascinating possibility. If this is an artificial object, the red surface might be functional. In nature, animals use patterns and colours to hide. A tiger has stripes to blend into the grass. In space, camouflage means blending in with the background radiation or looking like a boring rock. If a civilization wanted to send a probe across the galaxy without drawing attention to itself, they might coat it in a layer of tholins. To a distant observer, it would look just like any other random asteroid drifting through the dark. It would appear natural, old and dead. This layer could also serve as a protective blanket. Organic compounds are good at absorbing certain types of dangerous radiation. The red continuum might be a deliberate shield, a biological or synthetic skin sprayed over the metallic hull to protect the machinery inside from the cosmic rays that scream through the void. So when we look at this object, we are seeing a paradox. It has the heart of a refined engine, nickel, the skin of a warrior, armoured metal, but it wears the cloak of a hermit, the red organic layer. It is hiding in plain sight, disguised as a relic of the past while moving with the speed of the future. The story of this mysterious visitor takes a sharp turn when we stop looking at it as a silent rock floating through the dark and start listening to the roar of its movement. To understand the true nature of this object, we must look under the hood, so to speak. When astronomers began to analyse the data regarding how the object moved and interacted with the space around it, the numbers suggested something that defied the laws of natural geology. We are no longer looking at a simple asteroid. We are looking at what can only be described as the cosmic steam engine. The first clue lies in the sheer violence of its wake. When we observe natural comets, we usually see a gentle sublimation. This is a process where the sun warms the ice on the surface and it slowly turns into a misty gas, creating a long, beautiful tail. It is a passive event like an ice cube melting on a sidewalk but happening in the void. However, the data from this object tells a completely different story, which brings us to the phenomenon of the water exhaust. Measurements indicate that this object was ejecting water at a rate of nearly 40 tons per second. To visualize this, imagine the power of a massive industrial fire hose but multiplied hundreds of times. 40 tons of water every single second is an incredible amount of mass to throw overboard. If you were to stand near a waterfall of that magnitude, the roar would be deafening. But here, this violent expulsion is happening in the absolute parts of a vacuum. This creates a significant logical problem for scientists. In nature, for a small celestial body to release that much water with that much force, it creates a contradiction. The force of the spray acts like a rocket thruster. This is why the object accelerated or sped up as it moved away from the sun, rather than slowing down as gravity should have dictated. But the mystery is not just that it sped up, it is about how it held that water in the first place. Space is a vacuum, which means there is zero pressure. Liquid water cannot exist in a vacuum, it instantly boils away into gas or freezes into ice. For an object to shoot out water at 40 tons per second, that water must be stored somewhere under immense pressure before it is released. A loose pile of rock and a gravel, which is what most asteroids are, cannot hold pressure. It would just leak or crumble. A dirty snowball, which is what most comets are, would simply evaporate from the surface. For this phenomenon to exist, the object acts less like a rock and more like a rigid tank. It implies that there is a hard shell, a containment vessel capable of holding tons of pressurized fuel inside without bursting. It suggests a structure built to withstand the stress of expulsion. We are forced to ask, how does a natural rock form a high-pressure fuel tank? The answer is that it usually does not. This points us away from geology and toward engineering. This leads us deeper into the mystery, moving from the exhaust to the engine itself. When astronomers look at comets, they measure something called the active surface area. This is the percentage of the object's surface that is actually waking up, heating up, and releasing gas. For a typical comet, this number is very low. Usually only about 3 to 5% of a comet's surface is active. The rest is just dead cold crust that insulates the ice inside. However, this visitor was different. The data suggests that its activity level was much higher, sitting at around 8% or more. On paper, the difference between 4% and 8% might seem small, but in astrophysics it is massive. It is double the activity of a normal comet. This creates a question of energy. A natural comet is heated from the outside in. The sun shines on it, the surface gets warm and the ice reacts. But if this object is twice as active as a normal comet, it implies that it is not just reacting to the sun. It suggests that the heat might not be coming solely from the outside. If the object is warming up more than it should, based on its distance from the sun, we have to consider that it is generating its own heat. Think of a car engine. When you drive, the hood of the car gets hot, not because the sun is shining on it, but because there is a combustion reaction happening inside. The engine is burning fuel to create motion, and heat is the byproduct. If this object is a cosmic steam engine, that 8% active figure stops looking like a natural anomaly and starts looking like an exhaust signature. It suggests that there is a reactor or a power source deep inside the core burning fuel to generate the thrust we observed. The object was not just drifting, it was running. If we accept the possibility that this object is generating power and thrust, we immediately run into the biggest problem in space travel: heat management. This brings us to the strange observations of floating ice. Most people assume that space is freezing cold, so cooling down should be easy. But surprisingly, getting rid of heat in space is incredibly difficult. On Earth, if an engine gets hot air, flows over it to cool it down, or water circulates through a radiator, the heat moves from the engine into the air. But space is a vacuum. There is no air to steal the heat away. A vacuum is actually a perfect insulator, like a high-tech thermos flask. If you generate heat in space, it stays with you. If a spacecraft generates too much heat from its engines and does not have a way to dump it, the ship will melt from the inside out. So if this object is indeed a machine pushing out 40 tons of force per second, it would be generating a catastrophic amount of internal heat. It needs a radiator. It needs a way to vent that heat out into the dark. This provides a chillingly logical explanation for the chunks of ice and debris observed trailing behind or moving alongside the object. In a natural scenario, we call this fragmentation. The rock is falling apart. But seen through the lens of engineering, this looks exactly like a coolant discharge system. Imagine the system working like this. The internal engine heats up water to create steam for thrust. This drives the object forward. But the machinery itself gets dangerously hot. To cool the system down, the object takes some of that water, absorbs the excess heat into it, and then flushes it out of the airlocks. When this superheated water hits the absolute zero temperatures of space, it flashes. It turns into ice almost instantly. These are not pieces of the ship breaking off, they are blocks of spent coolant. They are the waste product of a thermal regulation system keeping the core stable. This paints a picture of a highly complex cycle. The object takes in energy or burns fuel, creating massive pressure. It releases this pressure as a jet of water 40 tons every second to push itself away from the gravitational pull of the sun. Simultaneously, to prevent itself from melting due to the intense heat of this process, it cycles water through its shell and ejects the superheated waste, leaving a trail of frozen ice chunks in its wake. When you combine these three facts, the image of a rock completely disintegrates. A rock does not hold 40 tons of pressurized water per second. A rock does not exhibit double the surface activity of its natural cousins, and a rock does not have a specific mechanism to manage internal heat by venting ice. What we are left with is the silhouette of a machine. It is a vessel that behaves according to the laws of thermodynamics and propulsion, not the passive laws of planetary motion. It breathes fire in the form of steam, it sweats ice to stay cool, and it accelerates with a purpose that nature simply cannot explain. We are watching a steam engine the size of a skyscraper chug its way through our solar system, and for a brief moment we were close enough to feel the heat of its exhaust. We have looked at the speed, the origin, and the strange silence of the object known as 3I Atlas. But to truly understand what this object is, we must look at how it moves. A rock falling through space tumbles blindly. It follows gravity and nothing else. But a machine has a purpose. A machine has a destination. When we analyze the path of 3I Atlas, we do not see the random chaos of nature. We see the precise cold logic of a navigator. The 1 in 20,000 chance to understand why the path of 3I Atlas is so shocking, we first need to understand the shape of our neighborhood. Picture our solar system not as a sphere but as a flat dinner plate. In the center is the Sun. Mercury, Venus, Earth, and Mars all orbit the Sun on this flat surface. Astronomers call this flat surface the ecliptic plane. Most comets and asteroids that come from deep space do not care about this plate. They fall in from everywhere. They dive down from high above the North Pole of the Sun, or they shoot up from below the South Pole. They come from random angles, crashing through our system like rain falling in a storm. But 3I Atlas did not do that. When astronomers traced its line of approach, they found something that made them check their numbers twice. This object entered our solar system moving almost perfectly flat along that dinner plate. To be precise, its path was within 5 degrees of the ecliptic plane. Why is this strange? Imagine you're standing in a large empty field. You're waiting for a friend to arrive. If your friend arrives by parachute, they could land anywhere. But if your friend arrives in a car, they must stay on the road. The road of our solar system is the ecliptic plane. Statistically, the chance of a random rock from deep space entering our system at exactly this specific angle is extremely low. The mathematics tell us that the probability is roughly 1 in 20,000. If this were just a rock, it won the lottery. But if it is an artificial probe, this angle is not an accident, it is a choice. Why would a navigator choose this angle? The answer is simple: observation. If you're a spaceship captain and you want to take clear pictures of the planet, you do not fly high above them or far below them. You fly on the same level. By entering on the ecliptic plane, 3I Atlas placed itself in the perfect front row seat. It aligned itself with the traffic of our planets. It maximized its ability to see, scan, and record the major bodies of our solar system. It did not want to just pass through, it wanted to watch. The Grand Tour. Once 3I Atlas aligned itself with our planetary road, it did not just drive straight through. It visited specific locations. This brings us to the second impossibility: the specific route it took. In space travel, we often talk about gravity assists or flybys. This is when a spaceship flies close to a planet to use its gravity to change speed or direction. Humans use this all the time. When we sent the Voyager probes to the outer edges of the solar system, we had to calculate the position of the planets years in advance to make sure the path lined up perfectly. 3I Atlas performed a maneuver that looks exactly like a calculated Grand Tour. Its path took it on a sweeping journey past the 3 most important rocky planets in our system. First, it swept inward past the orbit of Venus, then it crossed the orbit of Earth. Finally, it headed outward toward the orbit of Mars. This is the Goldilocks tour. In the Search for Life scientists talk about the Goldilocks zone, the area around a star where it is not too hot like Venus and not too cold like Mars, but just right like Earth. This object's path allowed it to scan all 3 potential candidates for life in our system in a single smooth motion. Consider the timing required for this. The planets are not stationary targets, they are moving bullets. Earth moves around the Sun at 67,000 miles per hour. Venus and Mars move at different speeds. To draw a straight line that intercepts the orbits of these 3 specific worlds requires incredible precision. If this is a natural object, it is a coincidence of cosmic proportions. It means a rock travelled for millions or billions of years in the dark and just happened to arrive at the exact second when Venus, Earth and Mars were arranged in a way that allowed for this close flyby. However, if we view this as a programmed machine, the timing makes perfect sense. This was not a random encounter, this was a reconnaissance mission. The trajectory was likely calculated billions of years ago from a star system far away. The navigator knew exactly when to arrive. It knew exactly where the planets would be. It threaded the needle between our worlds to gather data on the habitable zone of our Sun. It checked Venus, it checked Mars, and most importantly it passed close enough to Earth to perhaps pick up our radio signals, our television broadcasts, and the chemical signature of our oxygen-rich atmosphere. It followed the road and it checked the houses on that road one by one. The impossible tail. If the low angle and the planetary tour are circumstantial evidence, the third anomaly provides the physical proof. This is the mystery of the anti-tail. To understand this, we have to look at high school physics and the nature of comets. A comet is often called a dirty snowball. It is made of ice rock and frozen gas. When a comet gets close to the Sun, the heat warms it up, the ice turns into gas and the dust trapped in the ice flies off. This creates the famous tail of the comet. Crucially, the pressure of sunlight and the solar wind, a stream of particles from the Sun, pushes this dust and gas away. Think of the Sun like a giant fan blowing wind outward. If you hold a smoking torch in front of a fan, the smoke will always blow away from the fan. Therefore, a comet's tail always points away from the Sun. But 3i Atlas broke this rule. As the object moved through our system, astronomers observed something that should not be there. It appeared to have a tail or an ejection of material. However, this ejection was not pointing away from the Sun. The ejection was pointing forward, in the vacuum of space direction. Matters. If gas is shooting out of the back of an object, it pushes the object forward. That is how a rocket engine works. But if gas shoots out of the front of the object or in the direction of travel, it acts as a brake. We observed 3i Atlas seemingly ejecting material in the direction it was moving. In orbital mechanics, we call this retropropulsion. It is exactly what a pilot does when they want to slow down. Natural comets do not have brakes. A rock cannot decide to slow down. If a natural comet vents gas, it vents it from the side, facing the Sun where the heat is hottest. It does not selectively vent gas from the front to slow its descent. This anti-tail suggests active control. It suggests that as 3i Atlas approached the critical point in its journey, perhaps the point closest to Earth or the Sun, it engaged a propulsion system. It fired a thruster to fight against its own momentum. Why? If you are driving a car past a beautiful landmark and you're going too fast to see it clearly, what do? You tap the brakes. You slow down to get a better look. You slow down to maximize the time your sensors are pointed at the target. The existence of this forward-pointing feature is the strongest evidence against the natural rock theory. Nature does not build braking thrusters. Nature does not fight against the solar wind to adjust a trajectory. Only a navigator does that. The sum of the parts. When we look at these 3 facts separately, Lee, a skeptic might find excuses. You could say the 5-degree angle was just lucky. You could say the planetary tour of Venus, Earth, and Mars was just a coincidental alignment of the planets. You could say the anti-tail was just a weird pocket of gas bursting out at a strange angle. But when you put them together, the coincidences become impossible to believe. We have an object that enters on the only plane that allows it to see the planets. Fact 6. It arrives at the exact moment in history to sweep past all 3 habitable worlds. Fact 8. And when it gets here, it appears to use an engine to adjust its speed and position. Fact 3. A rock does not choose its path. A rock does not know where Earth is. A rock does not have brakes. 3i Atlas moved with intention. It treated our solar system not as a random collection of gravity wells, but as a target for study. It followed the rules of logic, the rules of surveillance, and the rules of controlled flight. It entered the room, walked down the centre aisle, looked at each of us in the face, and then slowed down to make sure it didn't miss anything. This was not a visitor stumbling in from the dark. This was a calculated arrival. The Absolute Navigator knew where it was going, and it knew exactly what it was looking for. The question remains: now that it has seen us, what information did it send back, and who is waiting to receive it? The deeper we look into the void, the more the void seems to be looking back. As 3i Atlas approaches, it is no longer just a rock moving through the dark. It is becoming a story that began long before we realized we were reading it. The silence of space is not empty. It is waiting. Factor 7. The WOW signal connection. To understand the true nature of 3i Atlas, we have to look back 48 years to a humid night in Ohio, August 1977. This brings us to one of the most famous unsolved mysteries in the history of astronomy, the WOW signal. For those who do not know the story, it happened at the Big Ear radio telescope. An astronomer named Jerry Eman was reviewing printouts of data, long sheets of paper covered in random numbers representing background noise from the universe. Suddenly, amidst the chaos of zeros and ones, there was a sequence. It was a burst of radio waves so strong, so clear, and so distinct that Eman circled it in red pen and wrote a single word in the margin: "Wow!" The signal lasted exactly 72 seconds. It was a narrow-band radio signal, meaning it was focused like a laser pointer rather than spread out like a light bulb. It came from a very specific frequency, 1420 megahertz, which is the frequency of hydrogen. In the scientific community, this is known as the water hole, a quiet frequency that many astronomers believe intelligent civilizations would use to communicate because it is a universal constant. For nearly half a century, humanity has listened to that same spot in the sky, hoping to hear it again. We heard nothing, just static. The silence was so absolute that many dismissed the event as a glitch or a secret military satellite. The coincidence of coordinates. But now we have 3i Atlas. When astronomers traced the trajectory of this comet backwards to see where it came from, the math revealed a chilling reality. 3i Atlas did not just come from a random direction. Its flight path, when traced back 48 years, aligns perfectly with the constellation Sagittarius, the exact coordinates of the WOW signal. This creates a terrifying narrative timeline. 1977. The signal arrives. It was a burst of high-energy data. A ping, a doorbell ringing in the dark. The silence. For 48 years, nothing happened. 25. The source arrives. The implication is that the signal was not a message to be decoded. It was an automated announcement. It was a handshake protocol. Imagine you are sending a package to a friend. You send a text message saying, "I'm on my way." That text message travels at the speed of light. You, however, travel much slower. The WOW signal was the text message. 3i Atlas is the sender finally catching up to its own voice. If the signal was indeed a greeting, then 3i Atlas is the guest. And looking at the data, we must ask ourselves, did we invite something in that we do not know how to send away? The mathematical probability of a random comet originating from the exact point in the sky where we received the only strong candidate for alien contact is statistically 0. This is not a coincidence, it is an arrival. Fact 14. The cyanide coma. As 3i Atlas gets closer, we are able to analyse its chemical composition. Comets are often called dirty snowballs because they are mostly made of frozen water, carbon dioxide and dust. When they get close to the sun, the heat melts the ice, creating a fuzzy cloud around the centre called a coma. Usually this cloud is harmless water vapour. However, the spectroscopic analysis of 3i Atlas, the method scientists use to identify chemicals by the light they reflect, has returned a result that has stunned the chemical community. The cloud surrounding 3i Atlas is not water, it is dominated by hydrogen cyanide, the scale of toxicity. Cyanide is one of the most deadly poisons known to man. On Earth, we handle it with extreme caution in tiny milligrams. The cloud surrounding 3i Atlas is not measured in milligrams, it is measured in millions of tons. The cloud of gas is massive, expanding to a size larger than the planet Jupiter. If 3i Atlas were a normal comet, this would be strange but natural. However, the cloud is behaving unnaturally. The density. The concentration of cyanide is far too high for a natural formation. It is statistically unlikely for a natural object to consist almost entirely of poison. The asymmetry. This is the most disturbing part. A natural comet vents gas in all directions as the sun heats it, creating a round, fuzzy ball. 3i Atlas is venting cyanide in a specific conical shape. It looks less like a cloud and more like a shield or a beam. The chemical message, why cyanide? If we look at this through the lens of artificial design, the presence of a massive cyanide cloud serves two potential purposes, neither of them comforting. Theory A, the fuel. Hydrogen cyanide is a high-energy molecule. It is possible that what we are seeing is not venting in the traditional sense, but exhaust. We might be looking at the chemical byproduct of a propulsion system we do not understand, spewing toxic waste as it travels. Theory B, the pesticide. In biology, organisms use poison to clear their path or defend themselves. If 3i Atlas is an automated probe, the cyanide cloud could be a defensive mechanism. It is a keep-out sign written in chemistry. It ensures that nothing organic can get close to the core without being sterilized. The visual is haunting, a dark object moving through space wrapped in a glowing green fog of pure death, acting like a lighthouse beam cutting through the darkness. It is not just a rock, it is a toxic bullet. Fact 16, the triple surge. If the cyanide cloud suggests a shield, the triple surge suggests an engine. Suggests an engine. In physics, we have the law of inertia. An object in motion stays in motion unless acted upon by a force. Comets follow smooth, predictable curves around the sun. Their speed changes gradually as gravity pulls them in and slings them out. It is a smooth, elegant dance. 3i Atlas, however, has broken the rhythm of the dance. Over the last 3 months, astronomers have detected 3 distinct surges in the object's brightness and velocity. These are not gradual increases, they are spikes. Surge 1 occurred when the object passed the orbit of Jupiter. Surge 2 occurred passing the orbit of Mars. Surge 3 is happening right now. The powering up phenomenon. These surges do not correspond to solar activity. A comet brightens when the sun hits it, but 3i Atlas brightened internally before the sun was close enough to cause such a reaction. The data looks remarkably like a machine shifting gears. The first surge was the wake-up call. Like a computer booting up from sleep mode, the energy output spiked, likely activating initial sensor arrays. The second surge was the course correction. The velocity changed slightly, not due to gravity, but due to what scientists call non-gravitational acceleration. In simple terms, it hit the gas pedal. It adjusted its path to ensure it would not miss its target. The third surge is the preparation. The energy output is now holding steady at a level 3 times higher than it was 6 months ago. The absence of natural law. Natural objects do not do this. A rock does not decide to speed up. A chunk of ice does not pulse with rhythmic energy spikes. The periodicity, the timing between the surges, is also mathematically precise. The time between surge 1 and surge 2 is almost exactly double the time between surge 2 and surge 3. This implies a countdown. The feeling among the scientific community, though rarely spoken aloud in press conferences, is that we are watching a powering up sequence. We are not observing a stone falling toward the sun, we are observing a system coming online. It is similar to standing on a runway and hearing the whine of a jet engine starting. At first it is quiet, then a low hum, surge 1, then the roar increases, surge 2. Now the engine is screaming at full capacity, surge 3. The machine is warm, the systems are active. And the most frightening realization is the destination of this energy. The surges are getting stronger as the distance to Earth gets shorter. The object is preparing for something. It is gathering energy. Whether that energy is for communication, for braking to enter orbit, or for something more destructive remains the ultimate question. The silence of the cosmos has been broken. The wow signal rang the doorbell. The cyanide cloud cleared the path. And now the triple surge tells us that the visitor is awake and ready to walk through the door. Mathematics is often called the universal language. While eyes can be deceived by illusions and sensors can be tricked by interference numbers, tend to remain stubborn. When we strip away the theories and the debates, we are left with raw data coordinates, brightness levels, and time signatures. In the case of this visitor, the data points do not just suggest an anomaly, they scream that something is wrong with our standard model of nature. When we look at the following 3 facts, we are no longer looking at a rock, we are looking at a machine. Fact 19. Active at impossible distance. To understand why this specific fact sent shivers down the spines of astrophysicists, we first need to understand how a standard comet behaves. A comet is essentially a dirty snowball. When it gets close to a star, the heat warms up the ice, turning it into gas. This gas shoots out, creating a tail and pushing the rock like a natural rocket engine. This is normal. This is expected. However, this process requires heat. A lot of it. The visitor, however, defied this basic requirement of thermal physics. The data shows that the object began to accelerate, pushing itself away from the gravitational pull of the star at a distance that was simply too cold for water or typical gases to vaporize. Imagine walking through a frozen landscape distinctively far from any fire or heat source. Suddenly, a block of ice sitting on the ground begins to boil and propel itself forward. That is physically impossible under natural conditions. Water ice does not turn to steam in a deep freeze. Yet this object did exactly that. This creates a profound problem for the natural rock theory. If the object was accelerating, it needed a push. If the push came from gas, the gas needed heat. But at that specific distance, the star was merely a bright point in the distance, providing nowhere near enough thermal energy to activate a frozen surface. So where did the energy come from? This brings us to the only logical alternative: internal energy. If the heat did not come from the outside, it must have come from the inside. In nature, asteroids do not have batteries. They do not have nuclear cores that generate heat to melt their outer shells. They are dead cold chunks of matter. The fact that this object exhibited activity at such a frigid distance suggests it was not relying on the passive heat of the star. It suggests that the object had a power source. Whether it was a stored chemical reaction, a nuclear battery, or some form of exotic heat generation, the implication is the same. The object was keeping itself warm. It was maintaining a specific operational temperature or activating a propulsion system independent of its environment. It was not drifting, it was driving. The acceleration at this distance was not a reaction to the sun, it was an action taken by the object itself. Fact 18. The 29-hour paradox. When astronomers observe a distant object, they cannot see its surface details. It is just a dot of light. However, they can figure out its shape by measuring how that light changes over time. This is called a light curve. Think of a potato spinning in the air. A potato has a long side and a short side, a flat side and a bumpy side. As it tumbles, the amount of sunlight it reflects changes. Sometimes it looks bright when the broad side faces you, and sometimes it looks dim when the narrow end faces you. By measuring this flickering, scientists can draw a rough map of the object's shape. Most natural objects in space are like potatoes. They are jagged, irregular and lumpy. Therefore, their light curves go up and down violently as they spin. The visitor presented us with the 29-hour paradox. According to the data, the object was rotating. We tracked a cycle that repeated roughly every 29 hours. But here is the impossibility: despite this rotation, the brightness of the object remained shockingly constant. It did not flicker, it did not dim, it did not flash. How can an object spin for 29 hours and reflect the exact same amount of light the entire time? There are only two geometric shapes in the universe that can do this. The first possibility is a perfect sphere. Imagine a polished billiard ball. No matter how you spin a billiard ball, it looks exactly the same from every angle. It is perfectly symmetrical. The second possibility is a perfectly smooth cylinder rotating on its main axis. Think of a shiny metal pipe spinning like a drill bit. If the surface is uniform, the light reflecting off it does not change. Nature does not make perfect spheres or perfect cylinders on this scale. Nature makes rough, cratered, collision-damaged rocks. Nature loves chaos and irregularity. A natural asteroid should look like a crushed car, not a showroom model. The consistency of the light during that 29-hour rotation implies a surface that is artificially smooth. It suggests a skin or a hull that has been manufactured to specific tolerances. It implies that the object is not a solid chunk of rock, but perhaps a vessel with a uniform outer shell designed to protect or hide what lies within. If the object is a perfect cylinder or sphere, it means it was engineered. The lack of variation in brightness is a form of camouflage. By presenting a uniform face to the observer, the object hides its true features. We cannot see engines, windows, or antennas because the skin is perfectly mathematically consistent. It is a silent, rotating monolith refusing to give up its secrets to our telescopes. Fact 20. The statistical impossibility. Finally, we arrive at the most damning piece of evidence, which comes not from physics but from probability. This is the law of large numbers. In astronomy, as in life, you usually find the common things before you find the rare things. If you walk onto a beach, you will see millions of grains of sand and thousands of pebbles before you find a rare gold coin. If you look into the ocean, you will catch thousands of minnows before you catch a giant blue whale. This rule applies to space as well. Our solar system is surrounded by a garage of debris. We know that for every giant rock out there, there are millions of tiny ones. Logic dictates that if objects are randomly flying into our solar system from interstellar space, we should have seen thousands of small boring rocks before we ever saw a massive strange one. We should have detected the cosmic equivalent of pebbles, but we didn't. The visitor was the very first interstellar object we ever detected. It was object number 1, and it was not a small pebble. It was a giant, it was an anomaly. It was shiny, shaped strangely, and moving under its own power. To put this in perspective, imagine you buy a lottery ticket for the very first time in your life. You have never played before. You buy one ticket and you win the massive jackpot immediately. Is that luck? Most statisticians would say no. If you win on the first try, the game is likely rigged. The fact that the first guest to enter our solar system was this massive, highly unusual object is statistically impossible if we assume it was a random event. If space rocks were entering our system randomly, our telescopes would have picked up the small common ones years ago. The absence of the small ones tells us that the arrival of the visitor was not a random roll of the dice. It was a selection. We did not see the small rocks because they were not sent. We saw the giant object because it was intended to be seen, or rather it was intended to be here. This flips our understanding of the universe upside down. We are not looking at a random sample of space debris, we are looking at a targeted mission. The statistical impossibilities suggest that the object did not drift here by accident. It navigated here. The odds of a rock like this hitting the bullseye of our solar system as the very first detected visitor are comparable to firing a gun into the air and hitting a bird that is flying on the other side of the planet. It implies that the trajectory was calculated. It implies that the timing was chosen. It implies that out of the vast empty darkness of the galaxy, this object bypassed the emptiness to come specifically to where we are. Summary of Part 7. When we combine these three facts, the picture becomes clear even if we are afraid to admit it. Fact 19 tells us the object has an engine or internal heater, allowing it to act in the freezing void where nature should be frozen still. Fact 18 tells us the object has an artificial shape, a perfect geometry that nature does not produce, hiding its internal mechanisms behind a smooth rotating shield. Fact 20 tells us that this meeting was not an accident. The math proves that we were likely a destination, not a drive-by. The numbers have spoken. They tell a story of propulsion engineering and intent. The object is not a rock. It is a probe, and it is watching us just as closely as we are watching it. As we reach the end of this investigation, the darkness of deep space begins to reclaim the mysterious visitor. We have spent our time analysing the light curves, the tumbling motion, and the strange acceleration of Oumuamua, but now we must face the philosophical and scientific aftermath of its visit. This brings us to what might be the most important realisation of all, something we can call the Loeb scale. This is not just about a number. It is about the courage required in science to ask the questions that others are afraid to whisper. For decades, the scientific community has operated under a very strict rule. If you see something strange in the sky, you must exhaust every single natural explanation before you're allowed to even think about extraterrestrial technology. You must assume it is a rock, a comet, an asteroid, or a mistake in the telescope until it is proven otherwise. This is a safe way to do science, but it is not always the best way to discover something new. This is where the perspective of astrophysicist Avi Loeb changed everything. He introduced a level of bravery that is rare in modern academic circles. He looked at the data, the extreme brightness, the flat shape, and the push away from the sun without a comet tail, and he refused to force a square peg into a round hole. The Loeb scale represents the probability that this object was artificial. While many scientists wanted that number to be 0 so they could return to their normal models, the data simply would not allow it. When we look at all the anomalies combined, the probability sits somewhere between 30 and 40%. Think about that number for a moment. If someone told you there was a 40% chance of rain, you would bring an umbrella. If a doctor told you there was a 40% chance a surgery would change your life, you would take it seriously. In the context of finding life beyond Earth, a 30 to 40% chance is not a statistical error. It is a sin blaring in the night. It suggests that for the first time in human history, we have a legitimate reason to believe we touched something made by another hand. But now the opportunity for direct study is gone. The object is departing. It is moving past the orbit of Neptune, diving into the freezing void where the sun is nothing more than a very bright star in the distance. It is travelling at speeds that our fastest rockets cannot hope to catch, drifting into the silence of the interstellar medium. This departure brings a heavy sense of melancholy. We had a visitor on our doorstep, and we only realised it was special when it was already putting on its coat to leave. This leads us to a haunting question. What did it see? If Oumuamua was indeed a probe or a piece of functioning technology gathering information, what data is currently stored in its memory banks? It passed closest to our sun, soaking up the solar energy, and it had a front row seat to the third planet from the star. It saw Earth. It would have detected the chaotic radio waves we blast out into the universe, Our television shows, our military communications, our music and our noise. It would have analysed the composition of our atmosphere, tasting the oxygen, the nitrogen, and the carbon dioxide that our industries are pumping into the air. Perhaps it saw a planet that is vibrant and blue, teeming with biological life covered in oceans and swirling clouds. Or perhaps if its senses are advanced enough, it saw a civilization that is struggling. It saw a species that is capable of splitting the atom and landing on the moon, but also a species that is constantly fighting itself over imaginary lines on a map. It saw our lights glowing on the dark side of the planet, a sign of intelligence, but also a sign of a species that has not yet learned to live in harmony with its home. If this object is a scout, the report it is carrying back to its creators might be complex. It might say that the inhabitants of this solar system are intelligent but dangerous, or it might simply catalogue us as a curiosity, a biological experiment that is halfway through its life cycle. And where is this data going? That is the great mystery of the departure. The object is tumbling back out toward the Lyra constellation, but it will take thousands of years to reach another star system. If it is sending a signal, that transmission is moving at the speed of light, racing ahead of the object itself. Somewhere deep in the galaxy, is there a receiver waiting for the handshake signal? Is there a massive archive of civilizations where Earth's file has just been updated? Or is Oumuamua a derelict, a piece of broken technology from a civilization that died 1 million years ago, still blindly collecting data that no one will ever read? We may never know the answer. The silence that follows its departure is louder than the noise of its arrival. However, this event has changed us. We can no longer look at the night sky with the same arrogance we had before. For centuries, humanity has suffered from a kind of cosmic loneliness. We assumed that if life existed, it was far away, primitive, or unreachable. We assumed that the silent drift of the stars meant the neighbourhood was empty. Oumuamua shattered that illusion. It proved that the universe is not just a collection of dead rocks and gas. It is a place where things travel, where technology might drift between the stars like a message in a bottle floating across a vast ocean. We are not the only ones throwing bottles into the sea, so as the object fades into the permanent blackness beyond our solar system, we are left with a final thought. We are not forgotten. The universe is vast, yes, and it is mostly empty space, but it's not devoid of observers. We have been noticed. Whether that observation was accidental or intentional, the result is the same. We are part of a larger cosmic ecosystem. This realization should not bring fear. Instead, it should bring a sense of connection and alert anticipation. We must stop looking at the ground and start looking up with more intent. We need to build better telescopes, better sensors, and better ways to intercept the next visitor, because there will be a next one. Statistics dictate that if one object entered our system, there are millions more like it drifting through the galaxy. Next time we must be ready to catch it before it leaves. My final message to you is simple. The story of Oumuamua is not a story about a rock. It is a story about our awakening. It is the moment humanity realized the door to the house was unlocked. So tonight, when you lay your head down, you can rest easy knowing that we are safe for now. The visitor has moved on, but do not let yourself become complacent. The universe is busy and traffic is heavier than we thought. Sleep well, but keep your eyes wide open when you look up at the sky. We are watching them, but now we know that they might just be watching us.